We've been looking at data type-oriented versus object-oriented programming in our organization of the Mo interpreter. And again, the advantage of the object-oriented approach was that we could add new expression types or even new value types now without changing any of our existing code, as long as we don't need any new operations on those different variants. But there's another sense that we can contrast here, which is functions versus objects. So far, to implement our object-oriented style, we're relying on Splait's level of function support, but you could also imagine implementing objects as the more primitive thing instead of functions. That is, right now, when we define a rectangle constructor here, it takes width and height, and it produces a list of tuples where we have functions embedded in those tuples. Furthermore, these functions are nested, and so they're referring to things in their lexical environment. That is, we're relying on having closures in Shplait to implement these objects like rectangle. The alternative would be to split a rectangle representation into two parts. The fields to hold, W and H, and the methods like area and is bigger than. So here, instead of defining a function, I've defined a macro, just to clarify that this is a rewriting step and not depending on having functions at the same way inside of Shplait. We do still have functions inside here, but these functions are not nested inside of other functions. They're just produced in the expansion of the macro. And in these functions, to refer to the fields, we need to pass a this argument into the function, so it can use something like this.w, which will really redirect to a find lookup to find the w field inside the object. So again, an object is going to be two lists, a list of fields and a list of methods. These methods are functions that are nested here only in list, but since they're not nested in other functions, we could lift them to the top, and that illustrates that they're a simpler kind of function than the one that we were relying on. So overall, we could have, say, a shape is a tuple of two lists, where the fields, we don't care about the internals of the shape, we just care that every shape has an area and is bigger than. And then we can implement rectangle, as we saw before, and we could implement square, and then we can have this, this macro syntax, similar to how we had before, a macro syntax for finding methods and calling them, and also another possible pattern for dot, which is field lookup, which finds the field by name. And so notice that to find a field, we find in the first of the object, that is this first list, and to find a method, now we're finding in the second of the object, that is in the second list. Meanwhile, once we find that method, the first argument that we pass in is the object itself, containing its fields and all of its methods, and that way a method implementation can refer back to itself using this, if it calls its first argument this. And if we put everything together in this way, then we can construct a rectangle and then get its field out or call its method like that.